Hi everyone, Sam from DMTI again. In this video, we're going to build off what we did with whole number subtraction to model how to visually model and use a couple different methods and also the key language structures for subtraction with decimals. Now, if you've watched the whole number subtraction example, you'll notice that the digits we're dealing with are the same as the last time, but we've just changed the place value. So in the last video, it was 342 subtract 153. But now we've changed the place values to where we have tenths involved in the problem. You'll also notice that the model is similar, but not identical. And that's because when we have place values in the tens, even if we've got some extra place values after the decimal, we're trying to kind of stay connected to what we might have done back in grade 2 or grade 1 with whole numbers, small 2-digit numbers, where we tend to build it more in a linear bar model. Again, that's going to be temporary. Over time, you have to transition to the more conventional place value models. But this will be a good example to build off what kids ideally would have done in prior years. And it really just has to do with the size of the numbers because they're not very large. We're not going to need a square for like 100, for example. However, if you start dealing with much larger numbers of digits with your decimals, you can make that transition to where then that what used to be 100 could be a 10, it could be a 1. There's all kinds of opportunities to build off of that idea. So we're going to first take a look at our partial differences that we've decomposed by place value. We're going to connect to our visual iconic model here by looking at the units of tenths. Now you can write a 0 digit in for the ones. I just sometimes choose not to for this particular example, just because I know in advance we're actually going to be working with that, and because I'm trying to connect it to the standard algorithm. So it just is a little cleaner in terms of notation, but sometimes it's nice to have that 0. So it's really up to you on that. So the first thing when we look at the tenths, we realize we don't have enough units of tenths to take 3 tenths away. So just like with whole numbers, if we were regrouping in the ones, we're going to move up here, and instead of decomposing a 10 into ones, we're going to decompose or partition, either term is correct, this unit of 1 into 10 tenths. Now, the drawing is going to be hard to do proportionally because we're dealing with such small units of place value, and I'm trying to keep a fairly large drawing, but it'll at least be close. So I'm going to take this unit of 1, and I'm going to partition it down to 10 tenths. So just like with whole numbers in the last video, we're going to move over here and we need to change our symbols to match what's actually happening with the model. Well, we don't have 4 units of 1 anymore. We only have 3. And now instead of 2 tenths, we actually have 12 tenths, which is written that way because there are 10 tenths in a unit of 1. So we actually have 12 tenths. So in the standard algorithm, we show we have 3 units of 1 and 12 tenths. So we're able to subtract the 3 tenths. We end up that we have 9 tenths left over. We could, and you can talk at this time about the procedures about making sure the decimals are lined up. It's not that that's not important, but our position would always be that if kids are relying on the neatness of their handwriting to be correct, that's less helpful than if they really force themselves to be thinking about place value. But it is nice to kind of keep the decimals lined up here. Now we're going to move over to our units of 1. We see we don't have enough units of 1, so we're going to have to decompose a unit of 10 into 10 units of 1. Now my drawing is not going to be perfectly proportional, but it'll at least give us a sense of what's happening here. So I'm going to move up to this unit of 10. And you'll notice these ones are a little larger, but we're kind of running out of space here. If you were to do this with kids, probably use larger strips of paper would be helpful. Or if they're working in a math journal, have them turn their paper to more of a landscape orientation so they've got a little more space horizontally to draw the bar model. So just like last time, we're going to need to change our symbols here. Well, now we have 20 in tens, or 2 units of 10. And now instead of having 3 ones, we have 13 units of 1. And from there, we can then do the subtraction, finding 8 units of 1. And then we can subtract our tens. And just like the suggestion last time with the whole numbers, once you've found the partial differences here, to make sure kids understand why we're going to then recompose those partial differences, it is nice to draw a new model that includes everything that was left over after we completed the subtraction. So you would have 10, 8 ones, and then the 9 tenths on the end of it. I hope this follow-up video was helpful, and we'll be building some more videos on different decimal operations and how they connect and build off of what kids learn about whole numbers and fractions.